Picture an immense asteroid hurtling towards Earth. Is it possible for humanity to evade a catastrophic event of unimaginable magnitude? Or are we powerless against celestial forces? These pressing questions drove NASA to send a specially built probe straight into the asteroid's path. However, the outcomes defied expectations. What unforeseen developments occurred? What are the implications for our safety? Join us as we delve into the perplexing phenomenon of an asteroid collision that has left NASA experts astounded and unable to provide a definitive explanation. Prepare for an exploration of a captivating voyage and the unveiling of enigmas beyond the cosmic boundary. An unexpected twist in NASA's daring asteroid deflection mission raises serious questions about our ability to protect Earth from celestial threats. The discovery of Dios and Doros in 1996 and the Doros moon hypothesis led NASA to select these asteroids for the DART mission to test planetary defense methods. Despite the enormous challenge of creating a precise probe and landing it on an asteroid, the success of the mission in changing the orbit of Doros exceeded many expectations, showing the potential of humanity to change the trajectories of asteroids. This success underlines the importance of continued global cooperation to protect the planet and lays the groundwork for future strategies. Imagine a huge asteroid hurtling toward Earth. A colossal stone races through the darkness of space, a silent foreshadowing of possible doom. As we watch this cosmic drama, an urgent question arises. Can humanity avoid such a massive catastrophic event, or are we simply at the mercy of the heavenly powers? Those critical studies prompted NASA to launch a purpose-built probe directly into the asteroid's path. Bold in its concept, the mission promised to change the trajectory of an asteroid and protect our planet. However, the results of this unprecedented undertaking disappointed all expectations. What unexpected events have occurred, and what are the consequences for our future security? Join us as we investigate a mysterious phenomenon, an asteroid collision, that has NASA experts baffled and unable to provide a solid explanation for its occurrence. Get ready to explore the exciting journey of the probe and discover the secrets beyond the cosmic boundaries. Engineers and scientists have worked hard for years to build a probe with a singular goal: an intentional collision with NASA's Double Asteroid Redirection Test, DART, spacecraft. The mission was clear from the beginning. The spacecraft was designed to test a new planetary defense method targeting two near-Earth objects, NEOs, named Dios and Doros. Dios, derived from the Greek term for twins, was discovered on April 11, 1996 by scientist Joseph Mannon using the Spacewatch telescope at the Kitt Peak National Observatory in Tucson, Arizona. Scientists speculated that Doros, the smaller of the two asteroids, may have a moon after NASA's Goldstone solar system radar detected unusual echoes in the Mojave Desert near Barstow, California. They became more confident about this possibility by analyzing changes in Doros' brightness over time using telescopes and radar images taken at the Arecibo Observatory in Puerto Rico on November 23, 2003. As Doros and its moon orbit the Sun, they sometimes dangerously is approaching Earth orbit. In 2003, Doros came within 0.048 astronomical units, AU, of Earth. 1 AU is the average distance from the Sun to the Earth. Although these asteroids do not pose a direct threat to Earth, NASA chose them for the DART mission to test new planetary defense technology. This technique involved a rapid collision of the probe with Doros, which slightly slowed its orbit and caused a permanent change in its trajectory. The challenge of this planetary defense strategy is not only to make a probe and collide it with an asteroid, but also to accurately determine the intensity of the collision. The goal is to push the asteroid just enough to steer it into a safe orbit, emphasizing the critical accuracy of the asteroid's deflection point. One could think of exploding these rocky asteroids, reminiscent of scenarios presented in movies like Armageddon. Placing an explosive charge on or inside an asteroid seems theoretically plausible. However, the main problem is the consequences of such an explosion. The resulting explosion would create many asteroid fragments, each of which would follow unpredictable trajectories and pose new threats to Earth. While people may resort to such dramatic tactics in a serious crisis, research supports a more pragmatic approach. Instead of destruction, the focus is on moving asteroids out of collision paths or pulling them away. Depending on where and when the threat is detected, relatively little effort may be required to guide an asteroid into a safe orbit. However, the margin of error is small, as insufficient or excessive thrust can still make an asteroid dangerous. This underscores the need for NASA's careful process with Doros, an asteroid placed far enough away to avoid potential danger regardless of the test's outcome. The nightmare of a large asteroid hitting the Earth is alarming. Immediate destruction of the impact zone would be catastrophic, and the entire society could face long-term post-impact death. The effects would be severe: tsunamis, fires, atmospheric dust, poison, and unexpected chain reactions of subsequent natural disasters. This sequence of events repeats the terrible fate of the asteroid Chicxulub for dinosaurs millions of years ago. Imagine a massive mile-wide asteroid crashing into Earth at 30,000 miles per hour. The energy it brings is like setting off a huge bomb, a whopping million megatons. We are considering a smaller version to assess the potential destruction. Imagine an asteroid the size of a regular house hitting Earth at the same super-fast speed. It would release the same amount of energy as the bomb dropped on Hiroshima, approximately 20 kilotons. Solid concrete buildings within a half-mile radius will be flattened, and wooden structures within a mile-and-a-half radius can be destroyed. It would cause significant damage to any city it hits. Now consider an asteroid as massive as a 20-story building with 200 feet on each side. This space rock could carry as much energy as the current largest nuclear bomb, 25 to 50 megatons. When it falls, it can flatten reinforced concrete buildings within a 5-mile radius. In fact, it could completely destroy major American cities. For a space rock to cause widespread damage to Earth, it has to be huge. According to scientists, an asteroid about 7 to 8 kilometers wide would do the trick. When such a giant asteroid hits our planet, it sets off a catastrophic chain of events. The impact creates a massive column of dust that covers the entire Earth, blocking the sun and causing a significant increase in temperature at the impact site. Such an event would result in the loss of billions of people and much of the planet's biodiversity. But experts believe that some life forms could survive even in such a disaster. According to NASA scientists, it would take an asteroid 60 miles wide to wipe out all life on Earth. A true historical example of an asteroid impact occurred on June 30, 1908, when a 40-meter asteroid hit the Tunguska region of Siberia. This impact damaged an area of forest comparable to London and has the distinction of being one of the most destructive asteroid impacts in modern history. The United Nations recognized the potential dangers posed by asteroids and designated June 30, 2016 as International Asteroid Day. The purpose of this day is to raise awareness of Earth's collision with asteroids, the countless celestial bodies drifting through space. Scientists, astronauts, and celebrities come together on Asteroid Day to highlight the dangers to our planet from asteroids that cross Earth's path. These events highlight the current vulnerability of space defense systems to potential asteroid impacts. Discussions of science fiction scenarios and possible solutions are central to potential threats, emphasizing the need for constant research and preparation. Recognizing the magnitude of this threat, international experts and governments around the world have launched a massive global asteroid defense program. However, providing adequate to combat this, scientists around the world continuously monitor all known near-Earth asteroids and comets around the clock. Every small change in the orbit of an asteroid is carefully analyzed, and in case of emergency, NASA issues an asteroid alert. 3 such warnings have been issued in the last 2 decades. Fortunately, we avoided tragedy every time the celestial bodies passed the Earth by tens of thousands of kilometers. However, relying on chance is not a profitable long-term strategy. Experts around the world agree that there are only 2 possible approaches to protect asteroids: forcefully remove asteroids from orbit or drag them away. Doros DART task was an example of the first method. Launched by NASA in 2021, DART is tasked with capturing a near-Earth object, NEO, on the DART spacecraft Doros to test a revolutionary planetary defense strategy. If the kinetic collision was successful, Doros' orbit would be permanently altered, slowing it down a bit. In fact, even modest changes in an object's orbit over time can have enormous long-term effects. As mentioned earlier, Doros does not harm humanity per se, but in principle, we can detect a threat years before it reaches Earth and direct it far enough away from us to forget about us entirely.